Hello friends, welcome back. This video, we explore the fascinating world of mass production and cutting-edge manufacturing machines revolutionizing industries. Stay tuned for an in-depth look at modern processes. The CBM-12 chain bending machine is an advanced and highly specialized tool designed for precision in chain production. Primarily used in the manufacturing of industrial chains, this machine plays a crucial role in the initial formation of metal links. It works by bending straight metal rods or wire into chain links, ensuring consistent shape and size throughout the entire chain. One of the standout features of the CBM-12 is its high-speed operation. The machine is capable of bending metal links rapidly, reducing production time while maintaining a high level of accuracy. This makes it an essential tool for industries where both efficiency and precision are critical. The CBM-12 also has adjustable settings, allowing manufacturers to customize the bending process based on the specific requirements of chain size and material type. Another key advantage of the CBM-12 chain bending machine is its versatility. It can handle different types of metals, including stainless steel, carbon steel, and alloyed metals, making it suitable for producing chains used in a variety of industries, from construction to marine applications. Overall, the CBM-12 is a critical component in efficient chain manufacturing. The Lucchini Wheel Rolling Mill Delaware 432P25X VID represents cutting-edge technology in the manufacturing of high-quality railway wheels. The process begins with billets, which are steel bars up to 8 meters long and 550 millimeters in diameter. These billets are formed using special steel grades specifically designed for railway wheels. Unlike traditional methods that use conventional saw blades, this mill employs hard metal disc cutters. The benefits of these disc cutters are significant. They reduce material loss, RHI, by 30%. Once the billets are cut, they are sorted into batches and placed in a vertical position, ready to be fed into the furnace. Using advanced manipulators, the billets are loaded into the furnace, where they are heated to 1,300 degrees Celsius, the ideal forging temperature for steel. With a throughput capacity of up to 40 tons per hour, the furnace efficiently processes large volumes of material, a testament to the mill's high productivity. After heating, the billets are descaled using a stationary robot that removes any surface impurities. Descaling is a critical step to ensure that the material is clean before moving to the rolling press, where the real transformation begins. The billet is precisely centered and pressed with 9,000 tons of force to form the pre-shaped profile of the wheel, marking the first critical stage of the wheel's formation. Following the rough rolling, the billet is transferred by manipulators to the next phase. 3 industrial robots cool the press dies and handle the material, automatically feeding it into the wheel washer, which is equipped with 15 CNC-controlled axes. The wheel rolling process is highly advanced, involving step rollers, lateral rollers, and an impression roller to guide the material through the mill. Adjustments to tool settings can be made in real time, allowing for optimal material flow and ensuring wheels are rolled with precision. Final pressing is performed by a 5,000-ton press, creating the finished step profile for the wheel. The flexibility of this stage allows for the production of various profiles, depending on the specific requirements of the client. The process concludes with the marking and measurement phase. Using a sophisticated oscillating needle marker, identification details are engraved onto the wheel, ensuring traceability. The wheels are then measured using 3D laser technology for final verification. Every step of the process is monitored and documented by an automation and part tracking system, ensuring that each wheel meets the highest standards of quality control. With the capacity to produce 280,000 wheels annually, ranging in diameter from 700 millimeters to 1,350 millimeters, the Lucchini wheel rolling mill is a leader in the global rail industry. The facility's integration of modern technology and automation ensures that each wheel leaving the plant is produced with unrivaled quality, precision, and efficiency, capable of enduring the rigors of high-speed rail transportation. Large diameter pipe cutting plays a crucial role in offshore construction, where precision and efficiency are paramount. The process involves cutting massive pipes, such as those with diameters of up to 4,500 millimeters and wall thicknesses of 120 millimeters, for point-to-point connections in the assembly of offshore structures like jacket legs. These connections require intricate cuts, including K-bevels, X-bevels, and other configurations necessary for high-quality welding preparations. HGG's CNC 3D pipe cutting machines are designed for such demanding tasks. They can cut various bevels, V, Y, K, and X, ensuring that each connection meets the exact specifications required for the job. These machines are capable of handling not only circular pipes, but also creating beveled holes in pressure vessels, bent plates, and other complex structures. The precision offered by CNC technology is critical for achieving tight tolerances, especially in harsh marine environments where structural integrity is non-negotiable. One of the key advantages of this cutting technology is its portability. The machine, along with its frame, is transportable by truck, allowing it to be brought directly to the job site. This flexibility is ideal for offshore construction projects, where transporting large pipes back and forth to workshops is often impractical and time-consuming. On-site cutting saves time and reduces logistical challenges while still maintaining high precision. HGG also simplifies the process by allowing clients to submit 3D CAD files or 2D drawings, from which the cutting data is generated. They create the NC data needed for the machine to perform the cuts, eliminating the need for the client to handle complex programming. This automation streamlines the process, ensuring efficient and accurate cuts for large shells, cans, drums, and tubular structures ranging from 50 millimeters to 8,000 millimeters in diameter. In essence, HGG offers a complete solution for complex thermal cutting jobs, tailored to the needs of offshore construction. United Offshore Services offers ropes capable of lifting the world. Our ropes are designed to handle ultra-heavy loads, whether at extreme lengths, heights, or depths. With top-tier equipment and unmatched expertise, we provide safe and reliable solutions for your lifting needs. We offer ropes in various sizes, from 6 millimeters to 500 millimeters, and partner with manufacturers who ensure the highest quality steel ropes. Our technology and skilled craftsmanship ensure that we meet your unique requirements with precision. We specialize in the marine and offshore sectors, using advanced machinery to handle weights up to 150 tons and circumferences of 300 meters. Each rope undergoes rigorous testing, ensuring it meets all standards and is certified for use. Our testing facilities, among the best in Europe, can detect even the smallest irregularities, guaranteeing maximum safety. Our commitment extends beyond ropes to include shackles and other lifting equipment, all of which are thoroughly inspected. Proper storage and maintenance are crucial, and we offer professional solutions to ensure your ropes are always in perfect condition. United Offshore Services. Join us and redefine the limits of lifting.